Hello everyone, myself Vivekananda Naik. I welcome you all once again for this interaction session on solid state physics course, which is being taught this semester by NPTEL with course code 2020 NOC 24 PS43. I am a PhD research scholar in the Department of Energy Science and Engineering at Delhi. So today we will discuss a few problems that will cover the week 4 of the. I request you to mute yourself. Sunil K, please mute yourself. Hello, can you hear me?
Hello, sir.
I request you to mute yourself so that only if you have any doubt, then you unmute yourself and ask me. But just mute yourself otherwise. Okay, so today we will solve a few problems that will be based on week 4 of the course content, solid state physics. It will mainly cover X-ray diffraction and some elementary problems related to um, the determination of structure of some certain crystals using X-ray diffraction method. There are different types of X-ray diffraction methods also, like one is device error method, which is otherwise called as powder method, and normal conventional methods. We'll also discuss the two problems we will be solving, and also some numerical problems related to interplanar spacing we'll be solving in this session. So let's start with question number one of today's session. The question says, uh, please mute yourself because I can hear some background noise of some horns. So I request you to mute yourself. So the question says, what are the Miller indices of the line of intersection of 1, 1, -1, and 1, -1, plane in a cubic crystal? The options are options A, 0, 1, -1 or 0, -1, 1. Option B, 1, -1, 0 or -1, 1, 0. Option C, -1, 0, 1 or 1, 0, -1. Or option D, 1, 1, 1 or -1, -1, -1. So these are the options. The question says, what are the Miller indices of the line of intersection of these two planes in cubic crystal? So we have to first determine what are those two planes, how they are drawn in certain cubical structure, and then we will see there is a common line of intersection between the two planes, and we will determine the Miller indices. So there are two planes is given. One is -1, 1, -1, -1, 1, and -1, -1, -1. So I'll give you a few minutes to try this question, and then we will discuss about how to approach this problem.
Sir, please explain, sir. I can't get it. I tried.
Okay, so if you see, there are two planes given. So if we draw these two planes with Miller indices -1, -1, 1, and -1, -1, -1. So if you see, suppose, so for simplification, I have drawn the cubes here. Suppose this is a cube. So this is one cube. This is one. This is two. There are two cubes here. Suppose we will take O, this point as O. So this will be x-axis. Sorry, this will be uh, x-axis. This will be y-axis, and this will be z-axis. But if we want to draw the planes -1, -1, 1, 1. So it will be -1, -1, 1, and -1, -1, -1. So if we draw these two planes, it will be difficult if we don't change the origin. So for our convenience, we will shift the origin. Suppose we shifted the origin to here. So this O prime is our new origin. Then accordingly, this will be X, this will be Y, and this will be Z. Is not it. So this is X, Y, Z. So we can name it as X prime, Y prime, and Z prime. So if you see this line, so it will be, since this is Y prime, so this will be minus Y prime. This is X prime. This will be, so this line will be, so there are these four lines. So this will be minus X prime. This will be minus Y prime. And if we draw the planes -1, -1, 1. So if you see this line will be included. So let me draw with another color pen. So -1, -1 means if you see this line, that is, suppose this is A and this is B. So this line intersects here at -1 at x-axis and -1 at y-axis. So this is the -1, -1. And if we see the Miller indices -1, -1, and 1, so it will intersect the z-axis along positive direction. So this is the plane. So this is the plane we are talking about. And this plane, this blue plane, this is -1, -1, 1. That is the first one. Similarly, if we will draw -1, -1, -1, so this line will be common to both of the planes. Then we can, so this is, since this is z prime, this will be minus z prime. So the intersection will be here. So let me draw with another type of color. So this plane you are seeing, this one is -1, -1, -1. So there are two planes. Suppose we will name it as A, B, C and A, B, C prime. So ABC plane corresponds to -1, -1, 1, and ABC prime corresponds to -1, -1, -1. Is it clear to you?
Okay, sir.
So if you see here, let me explain it once again. So we shifted the origin here. So this is O prime. So this is our x-axis, this is our y-axis, and this is our z-axis. So this is z prime minus z prime, x prime minus x prime, and y prime minus y prime. So if we draw the plane corresponding to, with respect to this origin O prime, then this blue shaded plane will be having the Miller indices -1, -1, 1, because it intercepts x-axis at -1, y-axis at -1, and z-axis has +1. And similarly, if you consider the same uh, origin O prime, then the plane shaded in orange color will be having the Miller indices -1, -1, -1, because if the origin is here, then this point is -1 along y, this is -1 along x, and this is -1 along z. So these are the two planes, and here we need to find the Miller indices of the line of intersection. So if you see the line, this is line. I request you once again, please mute yourself because there is some unwanted background noise I can hear. So I request you to please mute yourself.
Okay, sir.
Can you hear me? So please mute yourself so it will be better for me also. So if you see, we need to see this intersection line. So if you see this line, this AB line is the intersection line. And if we want to find out this Miller, simply we can say, since here you can see the option is 0, 1, -1 or 0, -1, 1. So this is the reverse of another. So we can take as the directions. So we need to find the direction of AB. We can be AB vector or BA vector. So AB vector will be having one Miller indices, BA vector will be having another Miller indices. So now if you see the points, this is A, this is B. For all these points A and B, Z is 0 because it is in XY plane. So here this point is -1. So if you see the point P is -1, 0, 0 because it is at -y axis, and point B is at 0, -1, 0. So if you see the point A has a coordinate -1, 0, 0. Point B has a coordinate 0, -1, 0. So if you talk about AB vector, then AB vector will be having the Miller indices. This will be AB vector means B minus A. So 0 minus 1 will be 1. -1 minus 0 will be -1. Then 0. And if you talk about BA, it will be exactly opposite. -1, 1, 0. So we can write it as 1, 1 bar 0 or 1 bar 1, 0. So this is the correct answer. And if you see the options will be option B, 1, -1, 0 or -1, 1, 0. So if you see these two planes intersect at the line AB. And if you see the line AB, it is intersecting at uh, A and B. So the coordinates of the A and B are such that they are intercepting Y at minus and X at minus. So if you see the uh, coordinates, it will be -1, 0, 0, 0, -1, 0. So the AB vector will be having the indices 1, -1, 0, and BA vector will be having the indices -1, 1, 0. Is it clear to you? Can you hear me? Is this clear to you?
Yes, sir. It is clear.
Okay, so we will proceed to the next question. The question says the distance between 1, 1, 1 planes in the face centered cubic crystal is 2 Armstrong. Determine the lattice parameter. Options are option A √3 Armstrong, option B 2 √3 Armstrong, option C 4 √3 Armstrong, or option D 6 Armstrong. So this is a relatively simpler question in related to the interplanar spacing distance. So the question says the distance between 1, 1, 1 planes in the face center cubic crystal is 2 Armstrong. And we need to determine the lattice parameter, that is the value of A. So the formula you know, this is the formula D is equal to DHKL is equal to A divided by H square plus K square plus L square. And then these are the options. So I will give a few minutes to solve this question and then I will discuss.
I got 1.5 root 3
Sorry, once again.
angstrom. 1.5
No,
root 3 angstrom units.
1.5 root 3?
Yeah.
No, it will not be 1.5 root 3. You see, the formula for interplanar spacing is dHKL equals to A divided by h square plus k square per h square. So here HKL value is given. HKL is 1, 1, 1. So D111 will be A divided by 1 square plus 1 square plus 1 square root over. So the lattice parameter will be
2
A
root 3, sir.
root 3 into D111. So here it is given the distance between 111 planes in center cubic is 2 angstrom. So it will be 2 root 3. So
Yeah.
A is 2 root 3 angstrom. So the correct option will be option B, that is 2 root 3 angstrom. So you know now how these relations are derived. Like if you talk about different types of crystal crystal structures, they have different expressions for calculating the distance of interplanar spacing. So for example, for cubic, since A is equals to B equals to C, so only the one thing you need to remember, interplanar spacings can only be calculated for the crystal systems having one angle 90 degrees, so or more than one angle 90 degrees. So if you see cubic, tetragonal, orthorhombic, monoclinic, triclinic, for those crystals we can determine the crystal the distance of interplanar spacing. If you see for cubic, A equals to B equals to C, so the relation is 1 by d HKL square equals to h square plus k square plus L square divided by a square. Basically, these relations are derived if you follow the lectures. So they are derived in a certain way. So we know there is some relations between the direction cosines and of the planes. So if you see there are quantities alpha, beta, gamma, so that alpha square plus cos square alpha plus cos square beta plus cos square gamma equals to 1. And if you put the values, if you draw some geometry and put the values of those alpha, beta, and gamma, you will get the relation d is equals to a. So you will get d is equals to a divided by h square plus k square plus L square root over. So this is for cubic. Simply for tetragonal, where A is equals to B but not equal to C. For in that case, the relation will be like this. For orthorhombic, since A, B, C both are different, all are different. So the relation will be like a square by a square plus a square by b square plus L square by c square. Similarly, since in hexagonal and monoclinic triclinic, the relation becomes a bit complicated due to some change in the geometry. So if you follow these formulas, you can easily calculate the value of the interplanar spacing if the lattice parameter and Miller indices is given, or if the distance of interplanar spacing is given, you can calculate the value of lattice parameter using these relations. And if we talk about, so let's move to the third question of the day. The question says a uh, body centered cubic crystal is used to measure the wavelength of some X-rays. We don't know the X-ray, the wavelength of the X-ray. The Bragg angle for first order
Sir,
reflection from
PPT
110
not
and
visible, sir. PPT not visible. Okay. Now okay, sir.
okay. So thank you for identifying the Bragg angle for first order reflection from 110 plane is 20.2 degrees. What is the wavelength of the X-ray used? The lattice parameter of the crystal is 3.15 angstrom. So here uh, it is based on X-ray diffraction concept. So here a body center cubic crystal is used to measure the wavelength of some X-rays. So here we want to measure the wavelength of X-ray that we are using, where the Bragg angle for the first order reflection from 110 plane is 20.2 degree. So the Bragg angle for first order reflection from 110 plane is 20.2 degrees. What is the wavelength of X-rays used? The lattice parameter of the crystal is 3.15 angstrom. The options are option A 1.54 angstrom, option B 0.54 angstrom, option C 2.17 angstrom, and option D 1.87 angstrom. So I'll give you a few minutes to try this question, and after that we will discuss how we will calculate the wavelength of X-ray that is being used in this diffraction method.
Sir, it is 1.54 angstrom unit.
1 minute. Yes, it is 1.54 angstrom. You're right. So if we solve this question, we know the formula for X-ray refraction for the peak to be seen or for the peak to be appeared. The relationship is 2d sine theta is equals to n lambda. 2d sine theta equals to n lambda. And here we don't know lambda. So lambda is unknown for us. This is the wavelength of X-ray. Then the question says angle for the first order reflection. So for first order means n equals to 1. Then the plane is given. So the HKL value is 110. So the distance of interplanar placing will be A divided by h square plus a square plus L square. So this BCC means body center cubic. So it is cubic. So it will be A by 1 square plus 1 square plus 0. So it will be A by root 2. So D is A by root 2. H scale from the scale we calculated D, and then theta is also given. So theta is 20.2 degree. So if you put all these in the formula, so it will be 2 into D. D will be A by root 2. So A is given the lattice parameter. Lattice parameter is A. So A is also given. A is 3.15 angstrom. It is 3.15 divided by root 2 into sine theta. So it will be sine 20.2 degrees is equals to n lambda. N is 1, so it will be lambda only. So if you calculate, lambda will be 1.538 angstrom, or to be more precise, one to be if you round it up to 2 digit, it will be 1.54 angstrom. So the wavelength of X-ray used is 1.54 angstrom. So the correct option is option A. Then proceeding towards the next question. The question says X-rays with wavelength of 1.54 angstrom are used to calculate the spacing of 200 plane in aluminum, that is FCC. The Bragg angle for first order reflection from this plane is 22.4 degrees. Find out the lattice parameter of the unit cell of the aluminum crystal. So this question is pretty much similar to the previous question, but here the lattice parameter is not known to us, so we will be calculating the lattice parameter. But what is given to us? The wavelength of X-ray used is given to us, which is exactly similar to the answer we got in the previous one, that is 1.54 angstrom. So this 1.54 angstrom wavelength of X-rays are being used to determine the information about the crystals. So here the plane is given. It is 200 plane. So FCC, the aluminum has an FCC structure we know, and the first order reflection comes from the Bragg angle, which is 22.4 degree and first order reflection. So we need to find out the lattice parameter of the unit cell. So the options are option A 2.08 Armstrong, option B 4.04 Armstrong, option C 5.07 Armstrong, or option D 6.06 Armstrong. So I'll request you to try this question. Since it is pretty much similar to the previous question, you won't be facing, I think, any problem in it. So after calculating, we will be going to discuss the next question.
Sir, is it 4.04 angstrom unit? Sir?
So the correct option will be option B. It is 4.04 angstrom. So if we
Yeah.
solve it, since it is pretty much similar to the previous question,
Yes.
1 minute. So again, the formula is 2D sin theta is equals to n lambda. N is equals to 1. Lambda is 1.5 angstrom. D, D is A by a square plus k square plus l square root over, since it is FCC. A we need to find out. HKL is given 200 and the Bragg's angle is 22.4 degrees. So 2D sin theta is equals to n lambda. That implies 2 into D is A divided by A square plus K square plus L square root over sine 22.4 is equals to 1.54 angstrom. Then A will be 1.54 divided by, so if you see this is So here will be 2 square plus 0 plus 0. So 2 square is 2. So these two will be cancelling out. It will be 1.54 divided by sine 22.4 degrees. So if you calculate, so the value of sine 22.4 is 0.1.54 divided by 0.38. It will be coming around 0.45 angstrom, or according to the options, if you see 4.04 angstrom. So this is the correct answer. Mhm. So this is the correct answer. The correct option is option B. I hope this is clear to you. So then we will move to the next question. So this is the fifth question of today's session. The question says, using a diffractometer and a radiation of wavelength 1.54 angstrom, only fast order reflection from an FCC material is observed when 2 theta is 121 degree. What is the interplanar spacing? So again, this question is pretty much similar to the previous question. So you need to apply the same formula, and here the value of 2 theta is given. So you need to find out the value of theta then. And then if you put all the values, then the only unknown can be easily calculated. So I'll give you a few minutes to try this, and then we will proceed to ask the next question.
Option is B, 0.885 angstrom minute.
Yes, the correct option is option B, 0.885 angstrom. So if we solve it, then again it is 2d sine theta is equals to n lambda. Lambda is given 1.54 angstrom. First order means n equals to 1. 2 theta is 121 degree. That means theta is 60.5 degree. And FCC is given. FCC means D will be A divided by A square plus K square plus L square root over. So again, here we don't need to find out the value of HKL, because we only need to calculate the value of interplanar spacing. So only we need to find out the value of D. So 2D sine theta is equals to n lambda. That implies D is equals to n lambda by 2 sine theta 1 into 1.54 divided by 2 into sine 60.5. So if we calculate the value of sine 60.5, it will be 1.54 divided by 2 into 0.87. So 1.54. it will be 0.885 angstrom. So the correct option will be option B, 0.885 angstrom. So these three questions are pretty much similar to each other in one question. So these are the questions. So here in question number 2, we simply calculated the interplanar spacing, and then in question number 3, we use the formula of X-ray diffraction, that is 2d sin theta is equal to n lambda, and here lambda was unknown, and all the remaining value, that is theta, d, and n was known to us. Then we calculated the value of lambda, and then in the next question, the question was pretty much similar, but the quantity which was unknown was different. So here lambda was given, so and all the other informations were given to us, and we calculated the value of A. And in another type of question, question number 5, the value of 2 theta was given. 2 theta means it is diffraction angle, it is not Bragg's angle. So it is diffraction angle, that is 2 theta. It is the angle between the incident and reflected or refracted ray. Then we calculate the interplanar spacing. So we don't need the values of H, K, and L, since we only need to calculate the value of interplanar spacing. So we are done with the 5 questions. Then is the question number 6. The question says the first 3 lines from the powder pattern of a cubic crystal have the following S values. That is 24.95 mm, 40.90 mm, and 48.05 mm. The uh, camera radius is 57.3 mm. The molybdenum K alpha radiation of wavelength 0.71 angstrom is used. Determine the structure of the crystal. Structure of the material. The options are option A, simple cubic structure, option B, body centered cubic structure, and option C, face centered cubic structure, and option D, diamond cubic structure. So these are the 4 options. This is a bit different types of question because it is based on powder method of crystal diffraction. So I will give you a few minutes to you to think about this question, how we will solve this question. So in the uh, um, course lecture content, you must have seen the you must have covered the lecture that explains. There are 2 lectures which covers the method of powder crystal method, the powder method of X-ray diffraction. This is otherwise called as Debye-Sirus method. So here, what happens? A powdered specimen is taken, and the diffraction patterns are obtained in some different way, a different manner. So we will discuss briefly about these techniques, and then we will go to solve the question. So I request you to please try this question, and then we will discuss.
Sir, please tell me, sir, this one.
So you just try to think about this question. Na? So you must have covered the lecture that discuss the powder crystal method. So try to think about this question, how we can approach this question, and then we will discuss.
Okay.
So if we talk about the powder crystal method, so in normal conventional method, that is Laus method and Bragg's technique, in those techniques that can only be adapted only if a single crystal of reasonable size is available. But if we see in general, it is very difficult to obtain very large crystals. So what generally done in this powder crystal method, therefore Debye Serer adopted a different technique. What they did, they took the specimen which was in the form of a well powdered sample, and they took it in a thin glass capsule, and then a narrow beam of the X-rays. Those are collimated by collimator lenses, and then those X-rays fall on the powder specimen S, and then the specimen, since the specimen is powdered, so it contains a large number of randomly oriented tiny crystals. So corresponding to each crystal or each gazing angle or glancing angle, there will be different types of reflections or refractions that will be detected in the screen. So if we talk about the experimental setup, so this is the X-ray source, and then there are two collimators. So this is S1, this is S2, and then it falls on the specimen S. So this is the powdered specimen S, and then there is a screen, and corresponding to the different angles, there will be diffracted X-rays. So now if you see, this is the screen. So this is the central spot. Then corresponding to the reflections, there will be lines like this. So if this is 2 theta, then there will be a solid cone formed. So like this, there will be cone formed. Then corresponding to another theta value, there will be cone formed. So if you see the screen, suppose this is the central part, then there will be some circular structures like this here. Then there will be structures surrounding it. So like this, there will be some structures. So this is basically the method of this is the method of this is the powder crystal method where powder sample is used. So here what happens? So this is the point and this is the distance. This is the value of A that is given. This is 24.95 mm, 40.90 mm, and 48.05 mm. So here, so these theta will correspond to some particular values of planes, and from those values of planes, because not all planes in a crystal shows the X-ray diffraction, so we will be discussing about in more details in the upcoming weeks when we will be solving problems. So one is called as atomic structure factor, atomic form factor. So in that subject, we will detail it in more details. So we will discuss it in more details. So here, corresponding to each sets of plane, we will be getting some diffraction peaks. So if you talk, suppose this is 2 theta, so suppose the total angle is 4 theta, and we know, suppose this is a circle. Oh no. Suppose this is a circle, then this is the center, then this is R. This R is nothing but the camera radius. Then this is the value of, suppose this is 4 theta, and this is L. So this is S, we can say. Then the relationship between L or S, R and theta will be, S will be equals to R theta. Then S is equals to R. The value of theta is 4 theta. So R is S by, so S by 4, we can say. But if you see, this S is in distance. So here, if you see the units, So in order to convert the units, we need to convert degree to radian. So if you see, the relationship between degree to radian is 1 degree is how much? How much radian? Can you tell?
Here r is equal to s by 4 theta, na?
Yes, S by 4 theta. Sorry.
Okay. 2 pi theta. In radians theta, 360 degrees, that is 2 pi theta.
Yes, so 1 radian will be 57.296 degrees. So approximately we can say 1 radian equal to 57.3 degrees. So this is, so if you convert this is to from radian to degree, so we can directly say the distance can be written as the Bragg's angle in degrees at which the reflections are observed can be directly. So suppose this is theta, so theta will be s by 4r, is not it? So this
Yeah.
theta, since s is in radian, sorry, since s is in, so the value of s is 57.3, so directly we can say it will be s by 4. We don't need to consider the value of r and other factors. So since 1, since 1 radian is 57.3 degrees, so simply we can say the angles in degrees at which reflections are observed are equals to s by 4. So the angles will be, one is 24.95 mm, so it will be 24.95 divided by 4 degrees. Then another is 40.9, so it will be 40.9 by 4. Then another will be 48.05 by 4. So this is 6.24 degree. Then this is 10.22 degree. Then this is 12 degree. So these are the Bragg's angle corresponding to which we are getting the values of, we are getting the diffraction peaks. And if we calculate the value of the sine square theta values, so the sine square theta values can be obtained generally in powder special method. What happens? So there will be some particular values of h scale that will show the diffraction peaks, and corresponding to those value of h scale, we can determine whether the crystal structure is like, whether it is simple cubic, whether it is body center cubic, or whether it is uh, face center cubic. But here, if you see, so in the upcoming week lectures, we will be discussing it in more details. So if these three angles are given, so if we determine it, so there will be certain sets of equations that we will solve it, and then we can obtain that the these angles corresponds to the crystal structure, that is diamond cubic. So here the other structure, that is simple cubic structure, body center, face center cubic, will not will be not will be the correct answer, because corresponding to those structures there are certain peaks that are observed that are not shown here. So these values corresponds to only diamond cubic structure. So uh, in the upcoming weeks, when we talk about the atomic form factor and atomic geometrical form factor, the atomic structure factor, then in that session we will discuss it in more details. And so we will move to the next question now. So the question
One
number
thing in
7.
there, please,
Sorry.
in the previous question, actually,
Yes.
that scattering angle is given that 2 theta, then why it is taken as 4 theta? Can you explain, sir?
Because if you see, so this is 2 theta scattering angle. So if you total think the total angle here it forms will be 2 theta and 2 theta. So it will be 4 theta. So if you take it, so this is the ring. So one ring forms here. So if you take the cross section, then this part will be 4 theta. So in order to get the relation, that is theta is equals to LR. So this is theta, this is R, and this is L. So this overall angle that it forms will be S. So this is the value of S is given. So the value of S corresponds to these values. So this point and this point, it corresponds to the value of S. So this is, so if you see this now, so this is the central part. There are fringes like this. So between these two fringes, the distance is S. So this S corresponds to the points here and here. And if you see between these 2 points, the angle it is forming, it is 2 theta plus 2 theta, it is 4 theta. So it will be 4 theta into theta is equals to LR. So 4, sorry, R is equal to L theta. Oh, sorry, L is equal to R theta. So
This
4
is called
theta
R.
R will be, so this will be the correct relation. So the value of S is only that. And since here R is equals to 57.3 mm, so the conversion factor is such that direct it will be S by 4 because 4 theta will be converted into radians. So since R is in 57.3 mm, so directly it will be S by 4. So if you do S by 4, then this will be the three values of theta that will show the Bragg's uh, peak, and corresponding to those peaks we can see or we can determine the exact structure of the crystal. So because if you talk about certain if you talk about the peaks that are observed in the crystals in the X-ray diffraction process, for simple cubic we can observe peaks corresponding to any sets of plane like 100, 110, 111. So we can get all these planes will be getting the peaks. But in case of body center cubic and face center cubic, there are certain conditions corresponding to which only those planes which obey those conditions, they will show the peaks at the X-ray diffraction pattern. So from those conditions, we can calculate the value of HKL. So for example, if you talk about the face center cubic, in case of face center cubic, the HKL value should be all even or all odd. So the first, so suppose here in simple cubic, this is the first member of diffraction, that is 100, but this 100 peak is not absent, it is not present in FCC. In FCC, the first peak corresponds to 100, sorry, 111, not 100, 111. So corresponding to these, so since HKL values are differing, or so the since HKL values are changing, so the values of theta will also change because 2d sin theta is equal to n lambda, the formula. So since here lambda is same, corresponding to a particular value of n, depending upon the value of d, and depend the theta will change. So these thetas will not correspond to face center cubic, body center cubic, or simple cubic. So it will only, so these will only correspond to diamond cubic structure. So in the upcoming lecture, we'll discuss it in more details.
Okay.
Is this clear to you?
Okay, sir.
Okay, so okay, we will move to the next question. The question says the Bragg angle corresponding to a reflection for which h square plus k square plus l square equals 8 is found to be 40.35 degrees. Determine the lattice parameter of the crystal. X-rays of wavelength 0.71 Armstrong are used and consider the first reflection is occurred. So just I was saying, so there are some particular values of HKL that will show the diffraction peak. So here the question says the Bragg's angle corresponding to a reflection for which h square plus k square plus l square equals 8 is found to be 14.35 degrees. So the Bragg angle 14.35 degree will only correspond to the Miller indices or the interplanar spacing distance of h square plus k square plus l square equal to 8. And then we need to determine the lattice parameter of the crystal where the X-rays of wavelength 0.17 are used and consider first order reflection is occurred. So one is first order reflection and another is members of the peak. So first order means n equal to 1 and first peaks corresponds to the planes, that is 100, 011, 110, 111 like this. So I'll give you a few minutes. The options are option A 4.05 Armstrong, option B 5.15 Armstrong, option C 6.25 Armstrong, and option D 6.75 Armstrong. So I'll give you a few minutes to try this question and then we will discuss. So did you calculate it?
Yes, sir, but I can't get answer. I'm trying, sir. I tried.
Okay, so try. Please take 1 or 2 minutes more and try to solve it until the correct answer.
Okay. It is 4.05 angstrom in its first option. A is correct, sir.
Yes, the correct option will be option A, that is 4.05
Or
angstrom.
yeah.
So if you see here, again the formula is 2d sine theta is equals to n lambda. The option is 2d expression is 2d sine theta equals to n lambda. So here theta is given, theta is 14.35 degrees. So you see this is Bragg's angle, but in previous question here these are not Bragg's angle, these are the angle that forms as the center. So the Bragg's angle will be theta. It will be s by 4 only. So theta is equal to 14.35 and the wavelength of X-ray radiation used is 0.71 Armstrong. And if you see the values of h square plus k square plus l square, it is 8. So d is a divided by a square plus k square plus l square root. So d equals a by root 8. So if you put the values in the formula, 2 into d is a by root 8 sine 14.35 degrees equals to n lambda. N is 1 and lambda is 0.71 Armstrong. So A will be 0.71 divided by, so this is 2 root 8 means 2 root 2, so it will be so it will be into root 8 2 sine 14.35 degree. So it will be 4.05 Armstrong. So the correct option will be option A, 4.05 Armstrong. Then moving towards the next question. The question says aluminum which has an FCC structure has a lattice parameter of 4.05 Armstrong. When a monochromatic radiation of
Sir,
1.79 Armstrong
PPT
is used.
not PPT not visible, sir.
Now,
Okay, sir. It is visible, sir.
okay. So, the aluminum which has an FCC structure has a lattice parameter of 4.05 Armstrong. When a monochromatic radiation of 1.79 Armstrong is used in a powder camera, what would be the first two S values? The camera diameter is 114.6 mm. Consider the first order Bragg's reflection from all the planes. So this is first order Bragg's reflection and the camera diameter is given, it is 114.6 mm. Then this 4.05 Armstrong, the lattice parameter is given 4.05 Armstrong and the wavelength of X-ray used is given 1.79 Armstrong. And here we need to find out the distance S where the peaks will be observed in the screen. The developed film, what will the value is? The options are option A 90 mm, 104.8 mm, Option B 164.7 mm, 172.3 mm. Option C 192.3 mm, 211.4 mm, or option D 213.5 mm or 265.6 mm. So these are the four options. So again, this question is based on the powder crystal method. So I request you to try this question and then we will discuss. Yes, can you tell me what will be the two values of S which corresponds to those peaks?
Can't get.
Sorry?
I can't get.
Okay, so if you see
I. I. Okay.
again here, the camera diameter is given. So diameter is 114.6 mm. So the radius R will be 57.3 mm. Since R is equals to 57.3 mm, so directly we can say so Bragg angle should be in degrees and the Bragg angles will be equals to S by 4. So the Bragg's angles will be equals to S by 4. This will be in degrees. Since R is in 57.3 mm, so we don't need to put any conversion factor. Simply S by 4 in degrees will give you the Bragg's angle. And if you see, for we are discussing about FCC crystals. So I just told you, in case of FCC, not all planes will give you the diffraction peaks. So only planes having HKL values, all even or all odd, they will give you the X-ray diffraction peaks. So can you tell me what will be the first two planes that will give you the X-ray diffraction peaks, which have all HKL values, all even or all odd? Yes.
111.
Yes. So the first one will correspond to 1 1 1. in 1, 1, 1, all are odd. So it will give you one peak. Then the second one, yes. So this is 1, 1, 1 means h square plus k square plus l square equals to 3. Then the next s square plus k square plus l square will corresponds to, so next will be 2, 0, 0, because 0, 0, 0 are not possible. 2 is even 0, 0, so it will be the second one. So here if you see h square plus here h square plus k square plus l square is equals to 3, so it will be first. Here h square plus k square plus l square equals to 4, it will be second. So this is the first member, this is the second member. So if you calculate, the formula is 2d sine theta is equals to n lambda, then 2 into, for first will be 2 into d will be a by s square plus k square plus h square. So it will be 4.05. H square plus k square plus l square will be root 3. 1 square plus 1 square plus 1 square. Then sine theta 1 equals to 1.79. Is not it? Because here 1.79 Armstrong is the X-ray wavelength, and first order Brash reflection will be taken. It is n equal to 1, lambda is 1.79. Then if you see sine theta 1 will be 1.79 into root 3 divided by 2 into 4.05. So it will be how much? This will correspond to theta is equals to 22.5 degree. But if you see, the Bragg angle will be s by 4. So s will be 4 into theta. So here theta 1 is 22.5. So s will be 4 theta 1 in mm. So it will be 22.5 into 4, that is 90 mm. So this is the value of S1. Similarly, for second, 2d sine theta is equals to n lambda. 2 into d is 4.05 divided by 2, that is 4 square, 2 square root into sine theta 2 is equals to lambda is 1.79 Armstrong. So sine theta 2 will be 1.79 into 2 divided by 2 into 4.05, which will give you theta 2 equals to, sorry, 26.2 degree. So S2 will be 4 theta 2, 26.2 into 4, which will be 104.8 mm. So this is 104.8 mm. This is 90 mm. So the correct option will be 104.8 mm and A 90 mm. Is this clear to you?
Sir, a small doubt. Actually,
Yes.
the Brock's angle theta is equal to s by 4. That please clarify once again how it is taken. Please tell me.
Okay. So if you see, so here S theta is equal to S by 4R, is not it?
Theta is equal to s by 4r. Is it correct, sir?
So here this total theta, if so 1 minute. So if you see, so this is R. Hmm. So for a circle, total is R. Then at the center, if theta will be 2 pi, then L will be 2 pi R, is not it? This is the
Yeah.
circumference of the circle. Na? So here 2 pi
Yes,
is 2
sir.
pi radian.
Yes. Uh,
So if you need to convert 2 pi radian to degrees, then we know 2 pi is 360 degree.
this.
Then 1 radian will be 57.3 degree. Here,
Yes. Yes, sir.
so then if you put here 57.3 degree, then this R will be direct 57.3 mm. Now clear?
Yes, sir. 1 radian is equal to 57.3 degrees, sir. Okay.
So if you are taking the angles in terms of degrees, then this R will be 57.3 mm.
Okay.
Then since here the R is already 57.3 mm, which is the conversion factor, then this S by 4 theta, uh, it is directly taken as S by 4 because here theta and this R, this gets cancelled out due to the conversion factor, because if you see 1 radian is equals to 57.3 degree. So here if R is given as 57.3 mm, then it will be only 4. Then it will be L. You got it?
Yes, sir. Okay, sir.
So all these questions where the value of R we are getting 57.3 degrees, so 57.3 mm, then directly we can say the angle it is forming corresponding to that S value will be S by 4. Sorry, it will be S by 4. So S will be 4 theta. So we did the same thing. S is 4 theta. So theta is 52.5. The S will be 4 into theta 1. That is 52.5 into 4, and it will be mm. As here, the conversion
Okay,
factor
sir.
is 57.6. That is already observed since R is 57.3 centimeter, 57.3 mm. Is this clear to you?
Oh, yes, sir. Yes.
Then similarly, in case of second member, the second member corresponds to 200. That will be h square plus k square plus l square will be 2 square plus 0 plus 0, that is 4. So it will be 2 square root, and if you calculate, the option will be option A, that is 90 mm and 104.8 mm. And again, if you talk about the next member, third member, then what will be the third member?
Odd number. Yes, sir.
Yes. Can you tell me whether it will be 222 or it will be 113? Can you say? Because 222 is all odd,
All
113
one
all
one
even.
one.
So,
113,
so
sir.
113, how you can say 113?
If again
Because
222 plane means it becomes 111, sir.
no, not 111. 222 for 222 plane. No, 111 and 222 planes are parallel, but they are not equal because they have different intersections. Na, if you see, these are
Okay.
intersecting at a by 2. That's why they are 222. These are intersecting at a. That's why they are 111. You got it?
Oh, yes, sir.
If you see, these are in increasing value of h square plus k square plus l square. Here it is 3, here it is 4. So the next value, if you see, this is 4 plus 4 plus 4, that will be 12. Here it is 9 plus 1 plus 1, that is 11. So here the next member will be 113. It will not be 4. So the fourth member will be 222. Is this clear to you?
Oh, yes, sir.
Okay, so we will move to the next question. So question number 9. So question number 9 says the reflection from 111 plane using copper K alpha radiation from a sample of copper powder FCC has an S value of 86.7 mm. Compute the camera radius. Wavelength of copper is 1.54 angstrom. The lattice parameter of the unit cell of the copper is 3.61 angstrom. Consider the first order reflection. The options are option A 57.3 mm, option B 86.7 mm, option C 43.35 mm, or option D 114.6 mm. So I'll give you a few minutes to try this question and then we will discuss. Yes, so can you tell me what will be the correct option? So if you see, this is 111 plane. So D111 will be A by 1 square plus 1 square plus 1 square. That is A by root 3. Is not it? So if you talk about the first order reflection, it will be 2D sine theta is equals to n lambda. So 2D is A by root 3. A is 3.61 divided by root 3 into sine theta. 2D sine theta is equals to n lambda. N is 1 and lambda is 1.54. So sine theta will be 1.54 into root 3 divided by 2 into 3.61, which corresponds to theta is equals to 21.68 degree. Is not it?
Yes, sir.
Then you see, we know 1 radian is 57.3 degree. So 1 radian is 57.3 degree. So 1 degree will be 1 by 57.3 radian. Then here 21.68 degree, 21.68 degree will be 21.68 divided by 57.3 radian. Now here, since we don't know the value of r, we will put s is equal to 4r theta. So s is 4r theta. So s we know s is 86.7. Here it is given the value of s is 86.7. So this is 86.7. 86.7 is equals to 4r into 21.68 divided by 57.3. So if you calculate 21.68 into 4 is 86.7. So this will cancel out. R will be 57.3 mm. Is this clear to
Yes,
you?
sir. Yeah, yes, sir. Same
That's
answer.
why. So here if you see this is theta, this is R, this is S. So when R equal to 57.3 mm, theta will be S by 4. Is this clear?
Mm. Yes, sir.
So this is the conversion factor. Since R is equal to 57.3 mm, directly we can say theta will be S by 4, where S is in millimeters and theta is in degree. Because the conversion factor of radian to degree is 57.3. Okay, so let's move to the next question. The question says, for some Bragg angle, the second order reflection from 200 plane of cubic crystal coincides with the first order reflection from which plane? So second order reflection from 200 plane will coincide with first order reflection from which plane? So n equal to 2, the plane is 200, then n equal to 1, what will be the plane? So that both have same angle, same Bragg's angle theta. So here theta 1, theta 2, theta 1 is equal to theta 2. Then what will be the value of H2? Sorry, this is HKL, H1, K1, L1. This is H2, K2, L2. So what will be the value of HKL if both have same Bragg's angle? Second order reflection from 200 and first order reflection from the H2, K2, L2. So we need to determine the value of H2, K2, L2. I'll give you a few minutes to try this question and then we will discuss.
Sir, is it to 200 plane?
It will be
200 plane.
not 200. Both can't be same because here if you see it is n equal to 1 and it is n equal to 2.
Sir,
You see 2d sin theta is equals to n lambda. This is the formula. So 2d1 sin theta by 2d2 sin theta will be n1 lambda by n2 lambda. Is not it? Why I
yes,
have mentioned, I have written here n1, n2, but lambda only? Because lambda is same and theta is same. So lambda gets cancelled out, theta gets cancelled out. It will be, so 2 gets cancelled out. So it will be d1 by d2 is equals to n1 by n2. Is not it?
yes, sir.
And we know d1 is, so d is a by h square plus k square plus l square root over. So h2 square plus k2 square plus l2 square root over divided by h1 square plus k1 square plus l1 square root over equals to n1 by n2. n1 by n2, n1 is 2, n2 is 1, so this is 2. Then h2 square plus k2 square plus l2 square root over will be 2 into h1 square plus k1 square plus l1 square root over. So h1 square k1 square l1 square root over will be, this is 200 is given, so it will be 2 square root over, it will be 4. Then h2 square plus k2 square plus l2 square root over equal to 4. Then h2 square plus k2 square plus l2 square equals to 4 square, that is 16. So if you see out of these four options, h square plus k square plus l square will be 16 only in
400
C,
plane.
in 400. Exactly. So the correct option will be option C, 400. So since here theta is
Yes,
same,
correct, sir.
but the order of reflection is changed. So the planes which corresponds to those orders of reflection will be again changed. So here for same brass angle, the second order reflection from 200 will be equal to the first order reflection from 400. Now it is clear to you?
Okay, sir. Yes, clear.
Okay, so we will move to the next question and the last question of today's discussion. The question says the first reflection, that is reflection corresponding to 100. Here you see it is first reflection. Here it is first order reflection. So order means n equals to 1, 2, 3. But first reflection means first member, that is first sets of planes which will result in diffraction peaks, because not all diffraction peaks. So the not all sets of planes show diffraction peaks. There are some particular sets of planes that will only show the diffraction peaks for a particular type of crystal structure. So here the fast reflection, that is corresponding to 100 from simple cubic, because we know simple cubic all the planes correspond to simple cubic structure. In case of simple cubic, all the planes show brass peaks, but here if it has center cubic, it will not be 100. It occurs at Bragg's angle of 28.2 to 28.7 degrees. Find out the Bragg's angle for fourth reflection, that is reflection corresponding plane is 200. Consider both cases first order reflection and the lattice parameter is A. So here n is equals to 1 for both. practice parameter is A for both. Here we need to find out the Bragg's angle where this is 100, this is 200. So this is pretty much similar to the previous question, but here there we need to determine HKL values, but here we need to determine the value of theta. In that case, in the previous case, theta was equal, but here since A is equal and N is equal, but here D is changing. So can you calculate and tell me what will be the correct option? So here N1 equals to N2, lambda 1 equals to lambda 2. Is not it? So it is N1 equals to N2, lambda 1 equals to lambda 2. So 2D sine 2D1 sine theta 1 will be 2D2 sine theta 2 because n lambda is equal. So using this relation, you can easily calculate what will be the value of theta 2 in the second case. So can you tell me what will be the value of theta? So if you see 2D1, A is same, so it will be D1 will be A by 1 square plus 0 square plus 0 square root over, so it will be 1. Then sine theta 1 is sine 28.7 is equals to 2 into D2. D2 is 200. It will be A by 2 sine theta 2. So 2 gets cancelled out, A cancelled out on both sides. So sine theta 2 will be 2 sine theta 1. Sine theta 2 will be 2 sine 28.7 degrees. So sine 28.7 is 0. So it is 2 into 0.48, that is 0.96. So theta 2 will be sine inverse 0.96 this sine inverse sine
73.73.
73.8 degree. So theta 2 will be 73.8.
Okay.
So this is the answer. The correct answer will be 73.8 degree. So I hope this is clear to you. So in
Yes,
today's
sir.
interaction session, we solved a few problems that was based on mainly that was based on X-ray diffraction and some interplanar spacing problems. And in the next interaction session, we'll be discussing more about reciprocal lattice, how they are formed, what are the utilities of the reciprocal lattice. So again, I thank you all for I thank you to join for joining in the interaction session. That's it for today's interaction session.
Next week, reciprocal lattice and next to packing factor about that one. No? You diamond structure you can explain.
Sorry.
In the previous problems, you told that next week how the
Yes, yes,
diamond
we will discuss
structure.
about that atomic structure factor and atomic form factors. We will discuss that.
Okay.
So, but I need to once verify whether that has been covered in the syllabus, because in the lectures, if these things are not covered, then it will be difficult for you also. So once
Okay.
it gets covered in the course content, then we will solve the problems according to it.
Mainly reciprocal lattice and diamond structure. Okay, sir. Next
Yes.
week. Okay. So this video will come in the tomorrow after 12. That is.
Yes, so this video will be uploaded in the YouTube channel around 10 or 11 a.m. So after that, you can watch it.
Okay, sir. Next, sir, one doubt. So actually, you are saying the problems based on the video 5 or video 4 like that given the schedule. Based on that one, you will explain, sir.
Sorry?
Actually, you are explaining the problems based on video 4, video 5 like that syllabus given based on that one, sir.
Yes, I am solving the problems that are based on that week lectures. That is, from for week
Week
2, there
lecture.
are some lectures. For week 3, there are some lectures. So the problems are based on those lectures only. So in the fifth interaction session, we will be solving the problems that will be based on week 5 lectures of the course content.
Oh, week 5. Okay, sir. So next to week 6, sir.
Okay.
Okay, sir. Thank you. Sir, in examination, will they provide a calculator in the online?